at reduction number 13, we will have the next action. So, reduction number 13. So, it will have this elist dot array equal to C, then elist dot place equal to T 3, and elist dot place equal to T 3, and this elist dot dimension equal to 2, and then it will also generate some code that T 3 equal to I into D 5, then T 3 equal to T 3 plus j. Okay. So, that is 13. At 14, at reduction 14. So, it will do that at reduction 14 is this one elist bracket close. So, it will do L dot place equal to a new temporary T 4 and L dot offset equal to another new temporary T 5. So, T 4 is equal to the constant part of C and T 5 is equal to T 3 into W. So, these two lines of code will be generated. At reduction 15, so it will have this E dot place equal to T 6, okay, and it will generate the code T 6 equal to T 4 T 5. This is a one dimensional array axis, T 6 equal to T 4 T 5. Then at reduction 16, so it will have the action that elist dot array equal to B, and then elist dot place equal to T 6, elist dot place equal to T 6 and elist dot dimension equal to 1. Okay. Then at reduction 17, it will have L dot place equal to T 7, another new temporary, and L dot offset equal to T 8. So, another new temporary, where T 7 is the constant part of B and T 8 is equal to T 6 into W, and so that is 17. At 18, at reduction 18, so E producing L, so it will generate a new, it will take a new temporary and E dot place equal to T 9, where T 9 is equal to T 7 T 8, T 9 equal to T 7 T 8. So, that is 18. Then 19, at 19, so it have L producing ID. So, this L dot place equal to ID dot place, that is J, and L dot offset equal to null. L dot offset equal to null. So, this is the action at 19. At 20, so it will have this elist dot array equal to C, elist dot place equal to T 10, a new temporary, and elist dot dimension, sorry, at 20 it is E producing L, sorry, so this is not correct. So, E producing L, so E dot place equal to I. So, E dot place equal to I. Then at 21, at reduction number 21, we have this one, this elist bracket close elist comma E. So, that part 21 we have elist dot array equal to C, okay, list dot place equal to I, list dot place equal to I, because this ID is C and this E dot place is already I. So, that is list dot place is I, and list dot dimension equal to 1. List dot dimension equal to 1. Then at reduction number 22, so it will do L reduction number 22 is this one, L producing ID. So, we will have L dot place equal to ID dot place, that is J, and L dot offset equal to null. Then comes reduction number 23. At reduction number 23, so we have got this E producing L. So, this E dot place equal to L dot place. So, L dot place is J. So, E dot place equal to J, and no code is generated. At reduction number 24, we have this one, elist comma E. So, elist comma E. So, for that elist dot array has to be copied. So, elist dot array is same as 21's elist dot array. So, elist dot array equal to C. Now, elist dot place is a new temp. Elist dot place is a new temporary T10, and elist dot dimension elist dot dimension will be equal to 2, and the code that will be generated is T10 equal to I into D5, and then T10 equal to T10 plus J. So, this is the code generated at 24. At 25, so elist L producing elist bracket close. So, it will do L dot place equal to elist L dot place equal to T11, a new temporary, and L dot offset is another new temporary T12, and it will generate some code. So, it will generate code like T11 equal to the constant part of the array C of C, and T12 equal to T10 into W. It will generate this code at 25. Now, at 26, I have E producing L. So, this E dot place, so this E dot place will be equal to L dot place. So, L dot place is T11. So, E dot place equal to it will be E dot place will be a new temporary T13, because this is an array. So, T13 is equal to the array access T11 T12, the array access. Now, reduction number 27. At reduction 27, we have this one L producing ID. So, this L dot place equal to I, L dot offset equal to null. Now, comes reduction number 28. At reduction 28, we have this E producing L. So, this E dot place equal to I. So, that is reduction number 28. At reduction number 29, we have this at reduction number 29, we have L producing ID. So, L dot place equal to id dot place, that is j, and L dot offset equal to null. Now, at reduction number 30 E producing L, so this E dot place equal to L dot place. So, E dot place equal to j. Now, reduction number 31, at reduction number 31 we have which one 30. So, this E producing E star E. So, for that it has to generate some code, that is a new temporary has to be generated, and E dot place will be a new temporary T14, where the code generated will be T14 equal to I into j, okay, multiplication of this E1 dot place and E2 dot place. So, 28 and 30. So, 28 is I and 30 is j. So, their product is taken as 30. Now, reduction number 32. So, in reduction number 32 we have got this rule E list producing id open parenthesis E. So, for that we have this L dot place equal to at 32 is E list something. So, this E list dot array has to be created. So, E list dot array equal to this new array D, okay. Then E list dot place equal to T14, and this E list dot dimension equal to 1. So, that is 32. Now, at 33, so it will 33 is this one L producing E list bracket close. So, E list dot array equal to D, then E list dot place equal to T14, and E list dot dimension equal to E list dot dimension equal to 1. Sorry, no, this is 32 is reduction 33 is this one L producing E list bracket close. So, it will be L dot something. So, 33 L dot place is equal to a new temporary T15, and this L dot offset is equal to another new temporary T16, where T15 code is equal to the constant part of the D array, and T16 code is equal to T14 into W. Now, comes reduction number 34. At reduction number 34, we will do that E list dot place is E producing L. So, E dot place equal to a new temporary T17, where this new temporary T17 is equal to T40, T15, T16. This is an array access. So, T15, T16. Now, reduction number 35. Now, reduction number 35. So, this is E plus E. So, 35 it will be doing E dot place equal to a new temporary T18, and then it will generate code that T18 equal to T13 plus T17, that is 35 at 36. So, it is again E plus E. So, now it will generate another new temporary E dot place equal to a new temporary T19, where T19 is equal to T9 plus T18. So, that is 36 and 37. So, it is L pro S this assignment statement. So, there is no action, only that ID dot place. So, that is L dot place of reduction 7, that is T2 T3, L dot place L dot offset, that is assigned as T19. Okay. So, in this way the final code that is generated will be final code that is generated. So, you can just club all these parts to get the final code. So, next we will be looking into another example where we will try to generate the code for some statement of some language. Okay. So, we will take this example: while A greater than B, do begin if x equal to y, then C equal to D, C equal to A plus B, else D equal to A minus B, P equal to Q plus R, and then x equal to y plus z. So, we will draw the parse tree, and then you should be able to follow the code generation portion that we have seen previously, and then we will see the final code. So, it will be like this. So, it is L M S, because there are multiple statements. So, we have to do it like this. Then this L gives me S, and this this S gives me the while loop. So, while M, the Boolean condition B, then another M, and then do, then another M, then S. Okay. Now, this M gives me epsilon. So, this B should give me the Boolean condition, that ID reloop ID. So, this ID is A, this reloop is greater than, so this is your B. Then this B gives us epsilon, and then this S should give me this begin end part. So, this is begin L end, and then this L, again there are two statements, the if statement and then this P equal to Q plus R statement. So, it should be L M S like that. This L should give me S, and this S should give me the if then else statement. So, it is if B, then M S N else S, sorry, L M then S. So, this is the if then else statement. Now, this B will give me that ID reloop ID, that is your x equal to y. This M should give me epsilon. Okay. Then this S should give me the C equal to A plus B, this assignment statement. So, this S gives me A, which is ID equal to E, this ID is C, and this E is E plus E, this E gives me ID which is A, this E gives me ID which is B. Now, this N will give me epsilon, this M will give me epsilon. Now, this S, so this S should give me the else this else part. So, that is D equal to A minus B. So, this S should give me A which is ID equal to E. So, this ID is D and this should give me E minus E. This E is ID, this E is also ID. So, this is A and this is B. So, this is the D equal to A minus B portion. Now, this M gives me epsilon. Now, this S will give me the next statement P equal to Q plus R. Okay. So, this P equal to Q plus R. So, it will have S producing A, A producing ID equal to E and this E giving me E producing E plus E. So, this is ID, this is ID. So, this ID is your C, sorry, this ID is your P. So, this is Q and this is R. So, this is doing P equal to Q plus R. So, we are done with this begin end part. So, this M gives me epsilon, then this S gives me this S gives me the assignment statement A and this A gives me ID equal to E. So, this ID is X and then this is E plus E, this E gives ID which is Y and this E gives ID which is Z. Okay. So, this is the whole parts tree. Now, if we think in terms of reductions, then this is the reduction number 1, then this is reduction number 2, this is reduction number 3. Now, after that we have got reduction number 4 as this one, then this is reduction number 5, then we have got this one as reduction number 6, reduction number 7, 8, 9, 10, 11, okay, 12. Now, this one 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, then this is 23, this is 24, okay. So, this is 25, oh, in between some numbers we have missed. So, this is 12. So, once this if then part is over, that is 17. So, 18 onwards we did mistake, 18, 19. So, these are wrong. 18, 17 is this reduction. So, then this reduction should be 18, this should be 19, this should be 20. After that this should be 21, 22, 23, 24, 25, 26, 27. Okay. Then this will be 28, this is 29, 30. Now, this is 31. This E producing ID, this should be 31, this is 32. So, this is 33, this is 34, this is 35 and this is 36. Fine. So, if you use this parse tree and follow the grammar rules that we have for this high level language statements. So, it will generate a code, and the final code that will be generated will look something like this. So, at offset 1, so it will generate code if a greater than b, go to 3, at 2 it will generate go to 13, at 3 it will generate if x equal to y, go to 5, at 4 it will generate go to 8, at 5 it will generate T1 equal to a plus b, 6 it will generate c equal to T1, 7 go to 10, at 8 T2 equal to a minus b, at 9 d equal to T2, at 10 T3 equal to q plus r, at 11 p equal to T3, at 12 generate go to 1, then at 13 it will generate T4 equal to y plus z, at 14 it will generate x equal to T4. So, you have to follow the rules that we have this for different production rules that we have for the grammar. In fact, all these rules that we have. So, all these rules for assignment statement or semantic action. So, this is for arrays. So, for other statements, so we can do that. So, that way if we follow those rules, then you will get this piece of code, and if you check this piece of code, so you see, so if a greater than b, go to 3. So, it comes to, so this is the body part, and the other if a is not greater than 3, then it will come to go to 13. At 13 it is outside the loop. So, it is computing y plus z and then x equal to T4. So, x equal to y plus z. So, this computation is being done. So, if it comes to 3, so that is the body. So, it checks if x equal to y, go to 5. So, 5 it computes that a plus b into T1, and then it is as T1 is assigned to C, then it goes it says go to 10, because it is skipping over the else part. So, it comes to the go to 10. So, T3 equal to q plus r, then p equal to T3, then it is go to 1. So, it is restarting the while loop, and if x is not equal to y, then it will go to 8. So, here it will do this a minus b, then d equal to T2. So, d equal to a minus b, and then it comes to the out of the if then else statement. So, p equal to q plus r. So, that is done, and then again go to 1. So, it will be branching to this. So, this way, so this piece of code faithfully replicates the code that we have for the while loop, and in this way we can translate any set of statements following the rules that we have discussed in our class for generating the 3 address code.